Welcome to myeyeacademy.com. I'm Professor Mahfooz from Pakistan. In this video, VHB 16.7 will talk about the biometry. So what is biometry? Biometry is application of statistical analysis to the biological data. We use it for identification of the personnel in colleges, hospitals and offices. What we do is we use the biological data like the fingerprints for the identification of the person. So we use the biological data to identify a person, and this is called biometric attendance. Now let's see what is biometry in the eye. You need this basic knowledge for how the normal eye works. This is a concave lens or a minus lens which diverges the light, and this is a plus lens which converges the light. This is 20 diopter plus lens, while the 25 diopter lens will converge it more as compared to the 20 diopter, while a 15 diopter will converge less as compared to the 20 diopter. So if you want more convergence than 20 diopter, you use 25 diopter. If you use less convergence than 25 diopter, you use 15 diopter lens. That's how the normal lenses work. Now, this is the eye, and the light is converged onto the macula. Now here we have got three eyes. The first eye is a normal length, the second one is slightly longer than normal, and the third one is shorter than normal. So in these eyes, in the first one, we normally need a 20 diopter lens to focus the light onto the macula. The second one is slightly longer, so we need less convergence, so we use 15 diopter lens. And the third one is shorter, so we need more convergence, so we need a 25 diopter lens. So if you need more convergence, you need 25 diopter. If you need less convergence, you need 15 diopters. So in simple ways, the longer the eye, the lesser with the power of the lens. If only length was needed to find out the power of the lens, then it was easy. Find out the length of the eye, and this formula will give you the power of the lens. But it's not that easy. It's not that simple. You need more information than the length of the eye to find out the power of the lens. In addition to the length of the eye, we need the shape of the cornea to find out the power of the lens we have to put into the eye. Look at these two eyes. They are identical, same shape, same length, and everything is the same. Now concentrate on this area and concentrate on the shape of the cornea. Look at that. The shape of the cornea will change in a second. Look at that. Look, it's changed. When the shape of the cornea is changed, now though the length is similar to the above one, it will need a different power lens. How that is? In the top eye, the shape of the cornea is different and the lens is focused onto the macula. In the second one, shape of the cornea is slightly flatter, so the light is focused short of the cornea. So what you need is, for the second eye, you need a small lens or a less diopter lens to focus the light onto the macula. So look at that. Both of them have got the same length, but because of the shape of the cornea is flatter in the second one, it needs a less dioptric power of the lens. So to find out the power of the implant or IOL or intraocular lens, we need two things. One is the axial length and second is the corneal curvature. So let's come back to the same thing. What's biometry? Biometry is application of statistical analysis to the biological data. Here in ophthalmology, we have got the biological data of axial length and corneal curvature, and we do the statistical analysis of these biological data to find out the power of the lens or IOL that we are going to put into the eye, and this is called biometry in ophthalmology. So how the biometry is done? We need two things: the length of the eye and the shape of the cornea. The length of the eye is found out with the machine called A-scan. This is the A-scan, and you touch the eye with the A-scan and it gives you the length from cornea to the retina. So that's how you find out the length of the eye with the help of the A-scan. Second, this is the keratometer, and with the keratometer you find out the shape of the cornea, and you put the shape and the length of the eye into a formula to calculate the power of the lens, and this is a formula. So you use the biological data for statistical analysis to find out the power of the implant in the eye. Thank you very much for being with me, and do subscribe the channel to see more videos. Thank you.